Aloha, everybody. This is Gigi from Kauai Community College. In this video, I will be talking about volume by shells. Okay, so let's get started. So let's talk about a solid. Suppose you have a two-dimensional shape like this, region R. And then what you're going to do for this problem is let's think about rotating it about the y-axis. Okay, so pause the video for a second. Visualize that region R rotated about the y-axis. Can you visualize that solid? Okay, doodle on your paper. All right, did you see something like this? Okay, so that's the solid. It's like a bell-looking shape with a hollow cylinder thing in the middle, because this part right here is hollow, right? Okay, so it kind of looked like that, right? Okay, now the question is, how are we going to go and find the volume of this solid, knowing that it is not any of the shapes that we know before, right? So the idea again, in the last series, what you were doing was slicing them, right? Now you're gonna shell them. So what does it mean to shell? What does it mean to shell? Okay, so let's take a look. Suppose you consider just one rectangular slice in that region. Okay, then the height would be f of x. The height would be f of x value, right? And the thickness is delta x, that one particular rectangular slice. Now, what you're going to do is you are going to rotate that, or you're going to revolve that slice, rectangular piece, about the y-axis, as if you did with the whole entire solid, right? But now just think about just one slice of it, okay? And when you rotate that about the y-axis, what are you going to get? Visualize it. Now, did you think about something like a cylinder looking? Of course, that's what it is, right? Now, let's take a look at that blue cylinder shell within that shape. The radius would be the x value because it goes from 0 to x. And the height is f of x. And the thickness is delta x. So here's the height that comes out of it, right? And there's the radius right there. So, and we know how to find a volume of a cylinder looking shape, right? So let's go ahead and take a look at that cylindrical shell. That would be that shape right there, right? Now, if you strain it out, slice it up, cut it up, strain it out, it's basically just a rectangular solid. The thickness is delta x, that's the thickness, right? And then the circumference of the circle is the length of that rectangular solid. And then again, the height would be your f of x value. So now that it's just a rectangular solid, we can find a volume, right? Length times height times how thick. So then the volume would be the length 2 pi x times the height f of x times how thick delta x. And then what are we going to do? We're going to go ahead and keep shelling this solid. So we're going to sum up a bunch of shells, like infinitely many shells. So then the volume of it would be, and when I say infinitely many, we are thinking the limit as n goes to infinity of the sum of all the shells. And that defines an integral. And that integral goes from a to b, 2 pi x, that would be your length, times the height, and then times how thick. That's that. And that is the general idea of what it means by finding volume by shells. Okay, let's take a look at one particular example. Suppose you are considering the area bounded by the x-axis and then by the equation y equals 3x minus x squared. And then it is being rotated by the about the vertical line x equal to -1. Okay, so let's put a graph up. Okay, let's put a graph up. There's the upside down parabola, right? And then here is the line y equals x, x equal -1. And we are going to rotate it about this red line right here. So visualize that for a second. We're going to rotate that solid part right there about the line y, x equal to -1. Okay. And so draw that on your paper. See what kind of solid you get. Pause the video. All right. Now, what you will have then should look something like this. There's that shape again on the other side, right? And then when you rotate it, you get a solid. So the solid looking something like that with a hollow part in the middle. All right. Now, what are we going to do when we are talking about volume by shell? Take one slice, one rectangular slice, okay, in between 0 to 3. Okay, in between 0 to 3. That's the slice that you're taking, between 0 to 3. Okay. In that rectangular slice, the height is the height of the parabola, which would be 3x minus x squared. And then the radius is from -1 to that x value. So that would be x minus a -1, which would give you x plus 1. That's the radius. And then, of course, the thickness is delta x. So then the volume of one particular shell that you were looking at is 2 pi times the radius, x plus 1, multiply by the height, multiply by how thick. And then what are we going to do with that? Infinitely many shells. So that's the volume. And then what are we going to do? That limit as n goes infinity of the sum is what defines an integral. And that would be an integral from 0 to 3 of that function. So I just simplify the red multiplied by the purple to get the yellow part there. Okay, and then the integration is just basic integration. Take the integral from 0 to 3, plug in the numbers, you have volume is 45 pi over 2. So I save you all of those tedious work, but you should go ahead and plug in 3, make sure that's the correct answer. All right, so in the last lesson, before this lesson here, we learned about the volume by slicing. Now we just learned about shelling. And then you also know that we could do integration with respect to x or y, right? So 2 choices there, 2 choices there. It looks like we have a table of 4 different choices. So I want you to go ahead and stare at this screen for a second and process the information. So now, in order to find volume, you have choices there. So which choice will you use? Will depend on the shape and depends on what you're comfortable with when you're looking at the solid. Okay, and that is it for today.